Welcome to another session of Grade 9 Mathematics, Chapter 2, Polynomials. Dear students, in this seventh part of the chapter, we shall discuss further the different algebraic identities and learn to apply them to solve the questions of NCERT exercise 2.5, question number 4 to question number 8. Without wasting a moment, let's quickly get to exercise 2.5, question number 4. Now, as you could read, question number 4 asks us to expand each of the following using a suitable identity. The first question is x plus 2y plus 4z to whole square. So how many terms are there inside the bracket? 3 terms. So try to recall an identity which has got 3 terms and then it's a square outside the bracket. Yes, the identity is a plus b plus c the whole square, which is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. I hope this is clear to all. Then all that we have to do is, after identifying which identity will be used over here, all that I have to do is identify what is my a. Yes, a will be replaced by x, b will be replaced by 2y, and c will be replaced by 4z. Then all that I have to do is replace the values of a, b and c in my formula. A plus b plus c the whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Now, as you could see over here, in the second line of the solution for the first question, all that I did is, instead of a square, I wrote x the whole square. Plus, instead of b square, I wrote 2y the whole square. Instead of c square, c is replaced by 4z. So, 4z the whole square. Plus 2ab. That is, a is replaced by x and b is replaced by 2y. Similarly, plus 2bc. Again, b and c are replaced by 2y and 4z respectively. Likewise, for 2ca, wherein c and a are also replaced. All that I have to do next is, and in the final line of the solution is, solve them. So x the whole square, what is the square of x? It is x square. What is the square of 2y? It is 4y square. What is the square of 4z? That is 16z square. And then 2 into x into 2y. That is 2 2s are 4, 4xy plus 2 2s are 4, 4 4s are 16yz plus 2 4s are 8, 8zx. As simple as this. So, what is the final answer? The final answer is x square plus 4y square plus 16z square plus 4xy plus 16yz plus 8zx. I hope the first solution is clear to you all. It is the only portion that you have to take care of is identifying which identity, algebraic identity, has to be used over here. I hope that's clear to everyone. If yes, then let's try to solve the second question. Here, the second question is 2x minus y plus z the whole square. Very similar to the identity a plus b plus c the whole square. It has got 3 terms and it is a whole square. Yes. So let us find what will our a, b and c be. A will be 2x. B will be minus y. Yeah, if it was plus y, we would have taken b is equal to y. But then here my equation is a plus b plus c. But then I have is 2x minus y plus z. So a will be taken as 2x, b will be taken as minus y, and C will be taken as Z plus Z. So all that I have to do is replace the value of A, B and C in my equation, which is A square plus B square plus C square plus 2AB plus 2BC plus 2CA, which will finally give me an answer that is 4x squared plus y squared plus z squared minus 4xy minus 2yz plus 4zx. Yes, I hope the second question is now clear to you all. Let us solve the next question, which is minus 2x plus 3y plus 2z the whole square. Again, three terms and it is a whole square. So the identity that would come into picture is a plus b plus c the whole square. So let us try to identify what is a. A is here minus 2x. What is b? B over here is 3y. And what is c? C is 2z. Again, I just replace the value of a, b and c and put it as minus 2x, 3y and 2z respectively in my algebraic equation or identity, and which will give me the final answer as 4x squared plus 9y squared plus 4z squared minus 12xy plus 12yz minus 8zx. Dear students, please ensure that you do the calculation part very properly. Dear students, try to solve question number 4 and 5 of from your textbook, very similar to what we did in question number 1, 2 and 3. And then check for yourself whether you have understood the concepts well. Yes? Let me do question number 6 for you. It is exactly, the same type of sum, but then since, the terms are involved as fractions, I'll just try to solve it for you. So the question is 1 upon 4a minus 1 upon 2b plus 1 the whole square. So which are the three terms? The first term is 1 upon 4a, the second term is 1 upon 2b, and the third term is 1. So all that I have to do is find what is my a, b and c of my identity. Which identity? A plus b plus c the whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So what will a be replaced by? A will be replaced by 1 upon 4a. What will b be replaced by? Yes, b will be replaced by minus 1 upon 2b. And what will c be replaced by? C will be replaced by 1. So in the second line, you'll find it over here that all that has been done is replacing the value of a, b and c, which gives me the final answer as 1 upon 16a square plus 1 upon 4b square plus 1 minus 1 upon 4ab minus b plus 1 upon 2a. I hope you have understood what needs to be done to solve these kind of questions. Let us try to understand this identity further by doing question number 5 of your exercise. The first question is 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Don't you think that we have somewhere seen these kind of polynomials? Yes, this polynomial is very similar to the identity that was used in the previous questions. Yes, wherein we use the identity a plus b plus c the whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Over here you could find that what we have been given as question is actually something in the form a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Now for that to check, what we have to do is Let's put it in the form of a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So what I've done as part of the solution is, in the first step of the solution, I've just rewrite the question. That is 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Then, to check whether this can be written as a square, I try to find whether 4x square is a square of something or not. Yes, it is a square of 2x. 9y square is the square of 3y. 16z square is the square of 4z. But then you will notice that I've written over here as minus 4z. Why so? Let you know. Then I have got my a square plus b square plus c square. So I've got my a, b and c. Yes. Then all that I have to do is put the formula further in 2ab plus 2bc and 2ca. And then put the value of a, b and c. That is 2x, 3y and 4z. While doing that, you will realize that in the first part, I have to have 12xy, which is 2 2s are 4, 4 3s are 12, 12xy. Had if I have put 2 into 3y into 4z, I would have got 24yz, that is plus 24yz. But what do I need? I need minus 24yz. So I have to take one of the term as negative. So which one shall I take negative? Whether 3y or 4z. Now if I take 3y to be negative, then I have to replace all the 3y with as minus 3y. And that will change the result of the previous step, wherein it is 2 into 2x into 3y, which gives you plus 12xy. But if I replace that 3y with minus 3y, it would give me minus 12xy, which is not something that I want. So what would I do is, to get minus 24yz, instead of putting the negative sign with 3y, I'll put it with 4z. So wherever 4z is there, I'll put minus sign. So in the next step, it is plus 2ca. What is c now? Minus 4z. What is a? 2x. Then let's just check whether we are getting the first step. 2x square is 4x square. 3y the whole square is 9y square. Minus 4z the whole square is 16z square. Now plus 2 2s are 4, 4 3s are 12xy. Yes, plus 12xy. Plus 2 3s are 6, 6 4s are 24. Minus 24yz. Yes, we are supposed to get minus 24yz. Plus 2 4s are 8. 2 into minus 4. Minus 8. Minus 8 into 2. Minus 16. Yes, minus 16xz. So we have verified that the given question is of the form a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So which identity does it resemble to? A plus b plus c the whole square. So what is my a? 2x plus what is my b? 3y plus what is my c? Minus 4z. So the plus minus 4z plus minus gives me minus sign finally. So the final answer would be 2x plus 3y minus 4z the whole square. I hope this particular solution is clear to you all. The question is actually given in the form of an answer to an identity. So you have to identify the question is of belongs to which identity, and then simply write which identity does it belong to. That is 2x plus 3y minus 4z the whole square. Let us try to understand it further with one more sum. The question is 2x square plus y square plus 8z square minus 2 root xy plus 4 root 2 yz minus 8zx. So again, it has got 6 terms and it very much resembles to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Let's check it out. 2x square. 2x square is square of what? 2 is square of root 2. So I'll write root 2x the whole square Y square is square of y. So y the whole square plus 8z square. 8 can be written as, if you try to factorize and find what is what are the factors of 8 or square root of 8, you will get 2 root 2. So 2 root 2 z the whole square. So I've got my a square plus b square plus c square. That is, I've got my a, b, and c. Just put those values in the identity and check whether you are getting the question or not. Over here, you will realize that root 2x has to be taken as minus root 2x everywhere, so that I can get in the final answer minus 2 root 2xy plus 4 root 2yz and minus 8zx. So this clearly states that the identity that I have used is correct. Hence, the answer will be a plus b plus c the whole square. That is, will be replaced by minus root 2x plus b will be replaced by y plus c, which will be replaced by 2 root 2z. So the final answer is minus root 2x plus y plus 2 root 2z the whole square. I hope you all understood the solution for this second question. So question number 4 and question number 5, which we have discussed as of now, resemble to the same identity. That is a plus b plus c the whole square. Now let us learn the next identity. That is a plus b the whole cube and a minus b the whole cube, and learn it further by applying it in question number 6. Now, question number 6 is, write the following in expanded form. The first question is 2x plus 1 the whole cube. Now, which identity does it resemble to? A plus b the whole cube. What is a plus b the whole cube? That is equal to a cube plus 3a square b plus 3ab square plus b cube. Okay, so what does my a stand here? A will be replaced by 2x and b will be replaced by 1. So all that I have to do is, in a square plus 3a square b plus 3ab square plus b cube, kindly note down that the identity is a cube. It is not a square as mentioned here. It is a cube plus 3a square b plus 3ab square plus b cube. And a will be replaced by 2x and b will be replaced by 1. So when you do that and solve it further, the final answer that you're getting is 8x cube plus 12x square plus 6x plus 1. I hope that's clear to all of you. If yes, then let us try to solve the second sum. 2a minus 3b the whole cube. Yes, so the question is 2a minus 3b the whole cube. Now, if we could recognize, it belongs to the identity a minus b the whole cube, which is equal to a cube minus 3a square b plus 3ab square minus b cube. So let us now utilize this identity to solve the question. What will a be replaced by? A will be replaced by 2a. And what will b be replaced by? B will be replaced by 3b. So in my identity, wherever a is there, I would replace that with 2a. And wherever b is there, I would replace that with 3b. And when you solve the identity, the final answer that you'll be getting is 8a cube minus 36a square b plus 54ab square minus 27b cube. It is as simple as that. Let me tell you the solution to the third question. The question is 3 upon 2x plus 1 upon the whole cube. Yeah, it looks different, but the solution is very easy. It's the same identity that shall be used. Yes, which identity shall be used over here? The identity that we shall use over here is a plus b the whole cube. And as you could see on the bottom of the page, what is a plus b the whole cube? It is equal to a cube plus 3a square b plus 3ab square plus b cube. So, as we have realized, what is the value of a? What should a be replaced by? A should be replaced by 3 upon 2x. And what should b be replaced by? B will be replaced by 1. So simply putting the value of a and b, that is 3 by 2x and 1 respectively in the identity, the final answer that we shall be getting is 27 upon 8x cube plus 27 upon 4x square plus 9 upon 2x plus 1. Isn't that easy? The question may look different with the fractions involved, but the method remains the same. Let us get to the fourth question. The fourth question is very similar. It also has a fraction, but then the method remains the same. The question is x minus 2 upon 3y the whole cube. As simple as that, the identity will be a minus b the whole cube, which is a square minus 3a square b plus 3ab square minus b cube. Please correct the identity. The identity will be a cube minus 3a square b plus 3ab square minus b cube. So all that we have to do is put the values of a and b. What is the value of a? A will be replaced by x and b will be replaced by 2 upon 3y. So when that gets replaced and you solve it further, the final answer that you'll be getting is x cube minus 2x square y plus 4 by 3xy square minus 8 upon 27 y cube. I hope you can do this, the calculation, and get the same answer as you have it on the screen right now. Yes? If then, let us try to use this particular identity, that is a plus b the whole cube as well as a minus b the whole cube, to solve a few more application based questions, like in question number 7. What is question number 7 of exercise 2.5? Write the following in expanded form. Yes? No. The question is evaluate the following using suitable identities. So you have been asked to evaluate what is 99 cube. Now, 99 the whole cube, right? So 99 can be written as 100 minus 1. Just see the second line of the solution for the first question. How did I write 99? 99 is written as 100 minus 1 the whole cube. Now, once I write 100 minus 1 the whole cube, I can easily use the identity a minus b the whole cube, isn't it? So what will a be replaced by? A will be replaced by 100. And what will b be replaced by? B will be replaced by 1. So once I put the value of a and b in my identity, a minus b the whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube, and solve it, I'll get the final answer as 9,70,299. See, I didn't multiply 99 into 99 into 99, that is 99 cube. But instead, I use an identity to get the answer in a quick manner. That is 9,70,299. Similarly, let's try to find what is 102, 102 the whole cube. Now, 102 can be written as 100 plus 2. That is 100 plus 2 the whole cube. So which identity would come into existence? Yes, a plus b the whole cube. What will a be replaced by? A will be replaced by 100. And what will b be replaced by? B will be replaced by 2. So simply replacing a and b with 100 and 2 respectively, you can solve it further and get the final answer as 10,61,208. Isn't it interesting that you didn't actually do 102 into 102 into 102 to get 102 the whole cube? But then you used an identity and you got the answer as 10,61,208 is the answer for the cube of 102. Let us do another sum, a number which is bigger than all this. That is cube of 998. Yes. So which identity would come into existence over here? Is the one over here a plus b the whole cube or a minus b the whole cube? Yes, you got it correct. It has to be a minus b the whole cube. So if I use the identity a minus b the whole cube, I have to first write 998 into such a form. So 998, that is 998, as you could see in the second line of the solution, I have written it as 1000 minus 2. Yes, 1000 minus 2 is what? 998. Now 1000 minus 2, the whole cube, resembles to my identity a minus b the whole cube. So what will the alphabet A be replaced by? A will be replaced by 1000 and B will be replaced by 2. So all that I have to do is replace the value of A and B as 1000 and 2 respectively and then solve it further. And when I get it correctly solved, the answer that I will be getting is 994011992. I hope the solution to question number 3 is clear to you all. And now you'll be able to solve the questions such as the ones given in question number 7 very easily by using the identities either a plus b the whole cube or a minus b the whole cube. Let us also try to understand how can this identity be asked further in the exam by solving question number 8. Now, what is question number 8? Question number 8 is factorize. We have been asked to factorize. The first question is 8a cube plus b cube plus 12a square b plus 6ab square. Now, how many terms are there? 4 terms. We have been asked to factorize it further, isn't it? So, what we shall do over here is, let us first identify the identity it resembles to. Yes, it resembles to the identity a plus b the whole cube, which should give the answer as a cube plus 3a square b plus 3ab square plus b cube. So let me check whether it actually resembles to the identity or not. How shall I do that? Try to verify whether it actually belongs to the same identity or not. Now 8a cube can be written as 2a the whole cube. And the last term, which is expected to be b cube, can be written as b the whole cube. And then fill up the value of a and b in 3a square b and 3ab square. And after filling it up, just calculate and see whether you are getting the exact question or not. Yes, over here it does resemble. So what does that mean? The value of a is 2a and the value of b is b itself. So the final answer would be 2a plus b the whole cube. Similarly, the second question, which is 8a cube minus b cube minus 12a square b plus 6ab square. What I should do first is just rearrange the terms. Yeah, the terms which are cube are written first and last so that I can easily resemble it to my identities. So what I've done is, to begin with, I've rearranged the question and wrote it as 8a cube minus 12a square b plus 6ab square minus b cube. And then simply try to resemble it to the identity a minus b the whole cube, which is a cube minus 3a square b plus 3ab square minus b cube. And as you can see over here, 8a cube is cube of 2a. The last term b cube is cube of b itself. And then just put the value of a and b as 2a and b itself. You will realize that the given question is of the form a cube minus 3a square b plus 3ab square minus b cube. Hence, I can conclude that the identity is a minus b the whole cube, where a is 2a and b is itself. So the final answer is 2a minus b the whole cube. Likewise, the third question too. The very first step is I'll rearrange the question so that the cubes are the first and the last term. So 27 minus 135a plus 225a square minus 125a cube. This is where I have rearranged the question. Then try to identify and recognize that it belongs to the identity a cube minus 3a square b plus 3ab square minus b cube. Here I realize that it belongs to the identity a minus b the whole cube. Hence, a is replaced by 3 and b is replaced by 5a, and that gives me the answer 3 minus 5a the whole cube. Isn't that interesting? Yes, let's do the fourth one too, which is very similar to the previous three sums. Here too, first you shall rearrange the question so that the cubes are the first and the last term. So the first term is 64a cube, and then minus 27b cube is written at last, so that I have the cube, one of the term which is a cube at the last. So 64a cube minus 144a square b plus 108ab square minus 27b cube. And then try to solve it to resemble to an identity which is a minus b the whole cube. Yes, it very much resembles to a cube minus 3a square b plus 3ab square minus b cube. So I can conclude that this particular form can be written as 4a minus 3b the whole cube. Isn't that clear? Yes. So which identity has been used? A minus b the whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. Now let us get to the fifth question and the last question of question number 8, which is 27p cube minus 1 upon 216, that is 216, minus 9 upon 2p square plus 1 upon 4p. Again, we have been asked to factorize. Yes, kindly note the question number 8, write the following in expanded form, is an incorrect statement over here. The correct question in a textbook is factorize, and which is what we have done with the previous 4 questions. Okay, so we shall try to factorize it again. The same steps. I'll first try to rearrange the question in such a way that the first and the last term are cubes. So 27p cube is written as it is. 1 upon 216, that is 216, is actually a cube. Cube of what? 1 upon 6. Yeah. So minus 216 will be written at last. And then after 27p cube, I will have minus 9 upon 2p square plus 1 upon 4p. Now try to identify whether it belongs to a cube minus 3a square b plus 3ab square minus b cube or not. For that, first I'll check whether what my a is. So 27p cube can be written as 3p the whole cube. And 1 upon 216, the last term, can be written as 1 upon 6 the whole cube. All that I have to do is then replace the value of a and b, that is 3p and 1 upon 6 in minus 3a square b plus 3ab square, and just verify whether the identity is correct or not. Over here, you must have realized, yes, it belongs to the identity a minus b the whole cube. So a will be replaced by 3p and b will be replaced by 1 upon x. So the answer is 3p minus 1 upon 6 the whole cube. I hope you have understood question number 4 to question number 8, what we have discussed in this part of the NCERT exercise 2.5. This is all for this part. Practice well all the sums so that you can perform well in your examinations. This is all for now. Take care of yourself until we meet next time with another session. Thank you.